Currently, I have two vacuum tube computers in this room. The first is this, a Bendix G15 from 1956, and we actually got this thing running in the previous episode, and it was really, really exciting. And the second one is this, the UE1. This is a homebrew vacuum tube computer that I've been building from the ground up for the past couple of years, and we're nearing completion on this, and it's starting to get really exciting. But both of these machines have something in common. Aside from the fact that they're both vacuum tube computers, and they both use a bunch of diodes for logic, they both have paper tapes. That's where I'm going with all this. They need paper tape to function. Now, they use paper tape in pretty dramatically different ways. The G15 has a little cartridge here on the front that reads the values of this paper tape into memory, and then it executes those out of memory. And this is 5-level paper tape, but the UE1 is going to use paper tape a little differently. It's going to use 8-level paper tape, and I've been building up a reader to read that in here, but because we don't have any random access memory or any credible amount of random access memory, it's going to be executing directly off of the paper tape. So it's going to read an instruction and execute that instruction the moment it reads it, coming off of this paper tape. Now, this paper tape is just a random one that I found on the floor at an event. I have no idea what the data is on this, nor do I really particularly care to find out, because it has absolutely nothing to do with what the UE1 here needs for its instructions. So I'm at an interesting place where I need to start punching new tapes, particularly for the UE1, so we can bring it up incrementally and start seeing what works and what doesn't work, but also so I can potentially punch new 5-level paper tapes for the Bendix G15 so we can start running new and exciting programs on it. But I don't have a paper tape punch. Well, a working one at least. I do have this guy right here. Good Lord. This is a Facit paper tape punch that I got from Mitch when I got that awesome PDP-11 haul down in Houston. So thank you so much for that, Mitch. It's been kind of sitting in the wings, waiting for me to get into it, and now's the time. So we are going to get this up and going. I hope we're going to get this thing up and going and punching initially 8-level paper tape. And if that all goes smoothly, maybe we'll take a look at how to potentially modify it to punch 5-level paper tape as well. But priority number one is going to be getting this thing onto a table. Why does it weigh so much? Did they fill it with lead? This thing weighs an absolute ton. Oh. This is a Facit 4070 paper tape punch. At least I think that's how you pronounce it. Facit, F-A-C-I-T, is a Swedish company. So I have absolutely no idea how you would properly pronounce that name, but I'm going to keep calling it Facit until the comment section explodes. Anyways, this is a pretty fully featured paper tape punch, but this particular one's in a little worse for wear. It does seem like it can do both serial, parallel, as well as serial with error code. And I think that's all down to this really nice looking card that's sitting here in the back. So the sticker on the top says that of the two DB25 ports on this edge here, the one closest to the power plug is the one for parallel, and that looks like it's pretty much going directly to the control circuitry inside. But it looks like we've got the serial card and it looks to be in really good shape. So that's probably what we're gonna use, because that means I can just connect it up to my laptop through one of those USB to RS-232 serial cables, and then I can just send it a binary file and it should completely punch it out. Now it's gonna do the punching on the front side here. You can see the solenoids along the edge here. This is what's actuating the actual punches to put holes in the tape. And you can see the tape is, interestingly, in 2 spools over here. If I pull this little thing down, I can slide this top spool holder off, and then you can see the actual spool of paper tape beneath it. Now this is 1-inch wide, 8-level paper tape, which apparently is worth its weight in gold. This stuff is like crazy rare. But I think the way this works is that it feeds from the bottom, and then as it punches it, it spools onto the top spool here. So that way you can then slice it and just pull it off on this top spool. But this is, ugh, that's gross. We need to do a lot of cleaning. And aside from cleaning, you can see that it's actually missing quite a few parts, but I don't think it's missing anything vital to the operation of it. It's missing a big cover on the front here, and there's supposed to be a really big clear plastic piece that comes all the way around it. And there's no panel on the back either. So everything is just really kind of exposed, which is an awkward place to be in, but I think all of the vital pieces are there and that this will be able to punch tape. Either way, we're gonna take it as far apart as I feel comfortable just so I can clean it because it's pretty filthy. And I'm gonna take nice high resolution pictures of all the stickers on it because I think some of these stickers are not gonna survive the cleaning. And that way we can reproduce stickers and put them back on there, or we just have them for our reference. But first step is starting to take stuff apart. So let's get to work. All right, let's strip this thing down, starting with the paper tape roll. Once you loosen up the rubber clamp, it just slides right off. Then we'll spin the whole thing around to get the two cards out, starting with this tiny jumper card, and it was an absolute bear to break free, but it eventually let go in pretty spectacular fashion. The serial card was much easier. It popped right out, no dramas. Next, I want to get this little metal cover off, and it's held on with two machine screws and square nuts. With both of those removed, it pulls right off. Behind that panel is another little cover held on with two screws. We'll pull that off, and that gives access to some more solenoids for punching holes. Next, let's see if we can get the switch panel loose so I can get to the back side of it. There's only 4 screws holding it in place, and with those removed, it pulls straight up. All the switches have blade connectors, but I'm going to leave them connected up for now. Next, let's get the paper tape wheel holder thing off. I don't know what it's called. It's locked in place with a circlip. Once that's been removed, it slides right off, revealing all sorts of fascinating stuff underneath. These levers in particular are super interesting. They have permanent magnets attached to them, and as they move through their range of motion, the magnets swing over reed switches, making or breaking the contacts. I love these types of reed relay switches, and it's really cool to see them here. This is about as far apart as I'm going to take it though, unless something proves to be really broken. So let's start trying to get this thing cleaned up. Starting on the paper tape wheels, I won't be shy about using Simple Green here, a heavy spray down followed by some scrubbing, and they really start to clean up. I'll give the same treatment to the jumper card. Since it doesn't have any traces or components on it, a simple scrub cleans it right up. Moving over to the front panel, the order of operations here is the same, and whatever grime was on here just comes right off with Simple Green. Aside from the missing pieces, this thing is really starting to clean up. For places where I don't really want to get in there with a rag because they're full of too much stuff, I use a dry paintbrush and just knock off all the nastiness. This works surprisingly well for this particular area. Fortunately, this little sticker just needed a little wipe down to come out looking almost brand new. But at the end of the day, trying to clean with a camera in between my arms is difficult. I ultimately just had to put the camera to the side and really get stuck into scrubbing it clean. I just put Cake rocking out on the rants in the background and just sat back and enjoyed the catharsis of cleaning up old electronics. Cleaning is going well. It's still got a ton of like scuff marks on it and it's missing all the plastic pieces, but for the most part, it's cleaning up really nicely and I'm not afraid to touch it anymore. But I don't have the main PCB in it at the moment because I want to turn it on and just do a health check of the power supply. These two main capacitors down here are in parallel and they're on the 24 volt rail. So they should be smoothing out that 24 volt rail. And these are the two that are the most kind of suspect looking. Everything else is really small like this, and I think those are probably going to be totally fine. So I want to flip the power on and see what happens. I'm skeptical if it's going to do anything at all, but at least we've got the main PCB out of there so we can't damage too much. So, well, here goes nothing. Let's give this a shot. Oh, something doesn't sound right. It's like it tried and then it gave up. I don't know what that means. The fan never spun. So, I don't know. We got some more troubleshooting to do. Looks like the whole thing went dead because we popped the fuse on it. I love fuses. They let me indulge in my send it attitude a little more than I probably should. Anyways, let's pull these capacitors out of circuit and see if one of them is the cause of our problem here. Measuring the lower capacitor, the multimeter shows 500,000 ohms of resistance. Not great, but nothing that would pop the fuse. But when I move the probe over to the upper cap, big oof, that's a fully shorted capacitor. Let's pull both of these caps out, and to do that, I gotta remove this back panel that has the parallel connector and power plug on it. The caps themselves have screws coming out the backside of them and big white plastic nuts that hold them in place. These are both 40 volt, 10,000 microfarad caps that were on the 24 volt rail in parallel. I don't have any replacements for these, but I do have this old Mallory cap that is 40 volt rated and 19,000 microfarad. The only problem is it's huge. I think I can squeeze it in here on the bottom and still clear everything though, but it's definitely a tight fit. This is almost exactly the same amount of capacitance. It's 19,000 microfarad versus 20,000 microfarad before. It's just all in a single package, which made it kind of tough to put around in there. But I think this should work fine. It's going to clear the card, it looks like. However, I didn't have a 2 amp slow blow fuse, so I've got like a 3 amp regular one in there. So it may pop immediately, or I don't know, maybe it'll work, or I don't know, maybe it'll let magic smoke out. We'll find out here. Let's flip the switch. We're hoping to see 24 volts right here. We got 29 volts, it's a little high. Could be because there's no load on anything here. And after switching it off, you can see there's very clearly not a bleed resistor on here anywhere, but that's good. It didn't immediately blow the fuse. I'm gonna try and find the other voltage rails and double check them, but if everything looks copacetic, we're gonna slide the card in and see if we can get it doing stuff. The schematics are not super easy to follow, and I'm pretty sure that this control board here isn't even included, but I'm pretty sure that no other voltage levels are going to be generated without this control board in place, so I think we need to slide this in next, and I think this has pretty much all of the driver circuitry as well as the receive circuitry. So we've got a little UART over here that's going to receive our RS-232. Then we've got some dip switches over here to select the baud rate, parity, number of stop bits, and so on. And then we have this little board right here. This is just a jumper board, it looks like. These connectors that are soldered on this side here connect front and back, and then the other half don't do anything. But it's got a little breakout here, so you could maybe solder some wires to it. This, I don't know, seems wild to me, but we're gonna plug it in because it's probably important that those are jumpered to each other. So we're gonna slide both of these boards back into the machine, and then we will flip the power switch on, and hopefully we don't see any magic smoke. Main PCB's back in place, so fingers crossed. Let's hope we see something out of this. Well, we got an error light. I mean, that's something. It's not what we wanted to see. And now we got to figure out what the error light here means. After a bit of reading, it seems that the error light here comes on whenever either the tape has broken or there's too much tension, which is probably just controlled by this little tension arm that's going back and forth here. So since we didn't have any tape loaded, that makes sense that the error light would absolutely come on. The tape feed button here to the right of it is also quite important. It seems that whenever you load new tape in, you need to push the tape feed button to grab a hold it and push it through. Since this button's quite important, but the EXT on the bottom I don't think is important at all. All I did was just unplug it and make a little bracket for another little push button down here. So this little push button here should do the exact same thing as the tape feed button. So let's see if we can go get tape fed into this thing and then see if our error light comes off there. And to feed it in, we've got 3 rollers over here. I think we go around this first roller, then in between the 2 bottom ones here, up and around this top roller, and that's gonna be kind of our tension signal there that's going back to it. And then we go around this bottom one and all the way over here to the other side. And as we pull around to the other side here, this is a really cool feature. You've got this guide here that you just slide the tape in like that. But the guide has 2 notches cut in it, one for 8 level tape, which is what we have on there right now, and one for 5 level tape. So I don't actually need to do any modification at all to get 5 level tape to load into this thing. I just have to swap out the spools. That's really epic. That's gonna make it easy. But now we need to bring this all the way up into here and then push our feed holes button to hopefully get it to feed in. So let's flip the power on here. And we did get an error message up here, so I'm gonna kind of push this tape up this way. I don't know if there's something else that I gotta do to get it to load correctly, but we're just gonna push our little button here and see if something happens. Whoa, things spun so quick. Okay, that cranks that wheel on the top. I think I'm gonna flip the on-off switch down there and keep that from happening. Okay. So the top wheel is not spinning like crazy anymore. But we need to somehow get this tape to catch and feed in, and I'm not entirely sure how you're supposed to do that. All right, I think I got it. It was just a little more finicky than I was expecting. Let's push the button here. Yeah, there we go. We aren't punching holes. Maybe I gotta do the feed holes, code holes. Oh, there we go. Oh no, all right. So I gotta push the feed holes. I mean, it punched, that's fantastic. You can see that if I do code holes here, it's punching code holes and making an absolute mess. I'm gonna have to vacuum like crazy. Look at the Chad coming out of this thing. That's hilarious. I think we need to hook RS-232 up to it and maybe start sending it stuff and see what happens. That's awesome. Let's try taking this thing for a test drive. I've got my laptop here with TerraTerm open. It's set to 600 8-in-1, which I'm pretty sure is what the serial card on this is set to, looking at the dip switches on the back. I've got a USB to RS-232 cable coming out of it. It goes then from a 9-pin to a 25-pin cable, then to a null modem adapter, then to a gender changer so we can get it all plugged in. This is like standard RS-232 shenanigans. I have a binary file that I'm going to send that should create a pretty unique pattern. It should start completely blank. It should fill up all the bits and then empty out all the bits, and then we should have alternating bits as kind of a delineation between the two. It's going to do that twice. The total number of bits it's going to send is 64 bytes. So 64 bytes should be 6.5 inches because it should be 10 bytes per inch with this type of paper tape. So I think we're ready to do this. We'll go ahead and flip the power switch on here. In TerraTerm, I'll click File, Send File. We'll hit Open and I think that's correct. Or not correct. That's totally not what I intended it to look like, but that could just be because I don't know what I'm doing. Let me double check the binary file. So the punch punched out exactly what I told it to. Unsurprisingly, it was 100% user error. I just got my binary wrong, but I think I have the binary correct now. It should print out twice as much because I've told it to. So let's give it another shot here. That's so cool. Oh, that's so much fun. All right. And if we look at the tape, that is exactly the pattern that I was hoping it would print out. All right, it seems to be working reasonably well, so let's send it a larger file. I've got a test pattern here that should come out to be about 30 inches. I think that's about how long I need to make a decent sized loop to use on the photo tape reader for the UE1. I think I have an alignment problem on that, and this will hopefully help suss that out. So let's go ahead and send this over. We're gonna do File, Send File, make sure that binary is ticked. And we'll go down and click UE1 test pattern, hit Open, and it should go. Yep. Oh, that's insane. That's crazy pants. I love it. It's so cool. The Chad is on another level. I'm gonna have to build a bucket or something to hold that. Oh, that's awesome though. But there it is. That is our test pattern that I should be able to use on the UE1 to see exactly where we are. That's really cool. Let's reload this thing for 5-level paper tape. After pulling the top wheel off and releasing the paper tape from the jaws of the punch, I'll remove the 8-level stuff and set it aside. The 5-level tape drops right down no problem. You just gotta be careful you don't catch the low paper detector arm is all. Then we'll route the tape along the same tensioning path as before, wrap it around the bottom and then into our guide where it lines up perfectly with the lower guide notch. Finally, we'll release the tension of the drive wheel and slide the tape right on through. 5-level paper tape is loaded up. It looks like everything's lining up correctly. I'm gonna punch essentially a duplicate of this program right here. This is just the number track for the Bendix. So I wanna punch it and then hold the two up to each other and make sure that they match perfectly. So that way I know that my method of punching tape here is correct. So we'll go ahead and load the file up here in TerraTerm. Open, and it should go. It's going. Whether it's going correct or not, I don't know. Oh, that's hilarious. That's so much fun. And look at that. Absolutely, completely perfect. 100% identical all the way through. All of the holes line up absolutely flawlessly. That is excellent. That means that our method works, and I can now punch longer tape on this kind of yellow-white tape here, and we can see how that works in the Bendix. And when I say longer, I mean a lot longer. If I just let the tape fly out the top, it would be completely unmanageable. So I want to make use of the upper wheel of this machine, which will wind the tape up for us automatically. The paper just needs to make a spiral around this post and then get taped into place. A few presses of the feed button shows that we've got it right. Then we just hit go and sit back and watch what mess it makes. This thing is absolutely stunning to watch. It really moves. 600 baud sounds slow, but in the context of punching paper tape, and more importantly, the pile of chad that this thing creates, 600 baud is really flying. The tape just screams by at a pace that I can barely keep up with, and even the frame rate of the camera is having a hard time parsing it. But it looked really cool going around the post in a spiral fashion and ultimately getting wound onto a completely separate roll. This particular shot was actually filmed at 120 frames per second and is being played back at 30 frames per second, which is a 4 times slow motion effect. And even then, you can only just barely see the punch pins moving. To get something mechanical to move this blazing fast really is special to see. Of course, at the end of it all, I have to break the vacuum out because this is just a hilarious mess. The primary purpose behind getting this paper tape punch going today was not actually to punch the 5-level paper tape that's currently loaded up on it. It was actually to punch this very specific tape right here. But since we did actually manage to get it to punch 5-level paper tape, I think this is an excellent opportunity to test something that's been a bit of a question within the Bendix G15 community for a little bit. And that is, what color paper tape is best? So the paper tape that we've been using up to this point is this one. This is the Diaper, which is a diagnostic program for easy repair. And you can see it's punched on blue paper tape. Well, I just punched the exact same thing on white paper tape, and we don't actually know if this will work in this machine because every single paper tape that we've come across for archiving has either been blue or black. And our thinking is that if you do it on white paper tape, too much light will pass through the paper in between holes and you'll never get a good logic low out of the photodiode reader. Now you might be able to adjust the bias of the photodiodes such that this works, but I don't particularly want to do that because it's set up to work really nicely with this blue stuff right now. But let's just go ahead and toss this in there and give it a test. So we'll go ahead and just punch it in like that, and then flip the reset button down here. All right, DC is coming up. We should see the light for that kick off. Yeah. It doesn't have the slots on the front here, so I can't actually see the paper tape moving around. But if I come over to this side, I can see the paper tape going by. So that was the first block, which was number track. We're starting the second block now. This should be the first block of data from Diaper. So we got our proper stop code there, so that's good news. It's at least reading somewhat okay. The click has gone off. All I gotta do now is flip the go switch on the typewriter here, and hopefully it hits the typewriter and starts executing. Fingers crossed. Well, it's executing, but it never hit the typewriter, which means it's executing the wrong things. And honestly, that's not too surprising because we're kind of expecting it to not have good logic lows as that paper tape's going by. I might be able to adjust it to fix that, but... Editing David jumping in here for a second, not for a second, for the remainder of the episode. Essentially, I went on for like another 3 minutes talking about, yeah, the different colors in paper tape are going to behave differently, and that's just the way the cookie crumbles, because that episode, not that episode, this episode is supposed to be about the paper tape punch, and the paper tape punch works absolutely perfectly. I'm in love with it. It's fantastic. I'm so glad it's going. Mitch, thank you so much for hooking me up with that. But let's put a button in it, slide that aside, and I want to know what the heck is going on with this, because I've been losing sleep over it. And as I was editing the video up, I got to the end of it and I was like, you know what, this sucks. We need to really figure out what's going on with this to wrap this episode up. And so it's like late in the day on Friday, and this video needs to be like up for patrons in less than 12 hours and for you guys in like 36 hours. So I'm real late in the game here, but I fired it up. I pulled out this amazing Keysight scope, which has 4 channels. We've got it hooked up, so let's check this out. Watch this. DC has come up, and we can see the clock is in yellow and it looks good. Data bit 1 in green looks good, but data bit in 2 has a little bit of noise on it. Data bit 3 in purple actually looks good too. So data bit 2 having noise on it could cause spurious bits to get flipped at some point in time. And I checked also data bit 4 and data bit 5, and they look fine for all intents and purposes. So I think the problem is on data bit 2, which makes sense. That's the photodiode that went bad and we replaced with a different photodiode. And I've got it adjusted pretty well for blue paper tape, but it might be a little bit too sensitive. So I'm gonna try and readjust it again and see if we can get this thing executing code off of the white paper tape as well as the blue paper tape. All right, bit number 2 is looking a whole lot cleaner, so let's hit the reset button here. You can see the sequencer going off. The paper tape reader should kick off. It's kicked off. That's good news. Hopefully it's reading in the number track right now, and then when it finishes in with the first block, it'll read in the next block, which will be the first collection of tests out of the diaper. Hopefully this fixes the problem. I can't see anywhere else that this could be causing an issue because bit number 2 looked good, and I checked bits number 1, 3, 4, and 5, and they all looked good. So let's hit the go switch here. Hopefully it hits the typewriter and starts executing code. Yes, it hit the typewriter. It's reading in the next block. I think that's great news. I think that means that it's working correctly. I mean, all we really have to do now is sit here and wait for it to at least finish one test and ring the bell. That bell will kind of be the definitive answer as to whether we are properly real deal executing code. And a lot of people left comments in last week's episode asking where the bell is. The bell is straight up inside of the machine. You can see they built this bell into the machine. It is a 120 volt DC bell. It's pretty awesome. Our test is slowly churning through. The blinking lights on the front here are going absolutely crazy. There it is. We got our bell. So I think that is definitive proof that we've got the white paper tape from our punch working on this machine. This punch right here, man. What an absolute legend. Facit, I love this thing. This is awesome. We can punch all sorts of new tapes for this. We have a ton of software backed up in digital files, so now I can start punching that software onto tape and executing it on this machine. That's super exciting. But next week, we are actually back into the UE1 to use that paper tape that we cut earlier so that we can figure out what's going on with my photodiode-based paper tape reader with that. So lots of exciting things to come, lots of Chad to make with this epic Facit paper tape punch. So I want to thank you all so much for watching, and I hope to see you in the next episode.